All right, let's continue on looking at how do we construct a confidence interval for a population proportion. Now, there are some requirements that need to be met, just like when we were setting up confidence intervals, or I should say t-intervals, to estimate a population mean, we had to meet a couple requirements. In other words, either your original population had to be normal, bell-shaped, and unimodal, or your sample size had to be larger than 30. Well, here we have three requirements that you're going to have to try to see if our situation allows us to be able to set up what we call a z-interval, a constant interval for a population proportion. First of all, the sample has to be a random sample. That has to be a given. Secondly, the sample has to be less than 10% of the population. And why this is, this goes back to really the 10% condition from Learning Target 8.3. We talked about binomial probabilities. What this allows us to do is that even though we actually are not replacing, so each time we pull something, we select something to be surveyed, those are dependent selections. Well, by having our sample be less than 10% of the population, we can assume independence, which makes our calculations a lot easier. And we talked about that back in Learning Target 8.3. That again lets us assume independence. Okay? That's why we do this in our calculations, so we can make calculations that are easier based on that independence. Now the third one helps us so we know our sampling distribution is unimodal and bell-shaped. Okay? We must have at least the possibility of 10 successes and 10 failures. If we have that, then we know that our sampling distribution is approximately bell-shaped and unimodal. Okay? It's fairly normal. And again, since our critical value uses z-scores, which come from a normal distribution, this is essential. So again, with the population proportion row, we estimate their values using the sample proportion, so that the requirement is a way of verifying that our sample size times our probability of, our sample size times p hat, which is the proportion of successes from our sample, has to be larger than or equal to 10, and our sample size times the proportion of failure has to also be larger than 10. If both these conditions are met right here, if both n times p hat and n times 1 minus p hat are larger than or equal to 10, then what that tells us is our sampling distribution, in other words, our distribution of all the samples of that size that come from the population sample proportions will be approximately normal and bell-shaped. So what this does, again, to make not to be too long-winded, this just assures we have a normal distribution. We'll call it normality. All right? So, again, let's go back to our Pew Research sample. They did a simple random sample of 1,007 adults and found 85% of them know what Twitter is. Based on that result, let's check the conditions for constructing a confidence interval of rho, the population proportion. Well, first off, number one, we said that the sample has to be random. Well, it says right here, a simple random sample. So condition number one, we have a simple random sample that has been met. Okay. 2, the sample has to be less than 10% of the population. Well, there's an easy way to check that. Just take your sample size times 10. Okay? And if you do that, that will give you the size the population has to be in order for us to be able to use this. That size or larger. So if you do that, if you take 1,007 times 10, you get 10,070. So what this number means here is that in order for 1,007 to be 10% of the population or less, our population has to be larger than this. Well, again, ladies and gentlemen, we don't know what, again, the population they're actually testing from. Is it a state? Is it a town? Is it U.S. adults? But we're assuming that the population is probably larger than 10,070. So as long as the population is larger than 10,070, our 1,007 adults will be less than 10% of the population, which allows us to then, ladies and gentlemen, assume independence and makes our calculations easier. So again, if you ever want to know what size the population needs to be at or larger than for that 10% condition to apply, just take your sample size times 10. Just take your sample size times 10. Okay? So that condition's met. Now the third one says that again, we need to assume we have a normal distribution. Well, in order to do that, n times p hat, which is, this case, 1,007 times 0.85, that has to be larger than 10, or equal to 10. Well, if you multiply those together and you do a little rounding, you get 856, and that is larger than 10. You do the same thing for n times 1 minus p hat, or the complement to p hat. So that's 1,007 times 0.15. How did I get that? I just take 1 minus 0.85, and that gives us 151, which is also larger than 10. So what this tells us right here, that this condition tells us we have a approximately normal bell-shaped distribution. Okay? So if all three of those conditions are met, then we can proceed and go ahead and construct a confidence interval. Now, if any of these were not met, then we would have to stop and say we can't go any further.